We are live. Hi, everybody, and welcome to the AWS AI community. This is our fourth event. We've got two amazing speakers this evening, Mahmoud and Matheus. But before we get started, just got a few things to run through. So for those of you who don't know us, we're Community Stack. We're on a mission to build the next generation of social infrastructure. Our kind of wider focus is essentially we basically develop and operate platform standards and operating models that help transform fragmented communities, charities, third sector organizations into one place. We act as essentially as an ecosystem operator. We support people and organizations who lead communities or basically trying to build shared foundations and insight layers that enable these ecosystems to thrive. So in practice, we own and operate several different communities across the UK, from data and AI leaders to platform engineering to DevOps to cloud-specific ones like the one here this evening. We're also doing a lot of work in the third sector, so we're helping to empower particularly rural charities try and get online. We've got a platform called Community Switchboard, which we've been developing for almost a year, going live in April, which is trying to address things like that. We're also looking at kind of wider kind of issues within the third sector and communities, etc., like platforms, for churches and all this kind of stuff. So there's a lot of stuff that we're doing, so like religious organizations, etc. So there's a lot of amazing work that's going on in this area. But really, community is very powerful and it should not be limited by a lack of resource or technology, and that's kind of our main focus and premise there. So for those who don't know me, hi, I'm Ethan Sumner. I'm the co-founder and CEO of Community Stack alongside my amazing co-founder and CTO, Mercedes Moxon Greenfields. We're both two innovators from South Yorkshire. We've got kind of big ambitions of what we're trying to do. As a kind of business, we're always wanting to reinvest and support kind of end users, charities, community groups, etc. That's kind of our main aim and focus. But here tonight, we've got the AWS AI community. You please feel free to join our meetup group. There's a QR code which you can scan right there, and it kind of brings us to the main meetup page, which is quite cool. And you can see all the available events that we've got upcoming. We've also recently launched chapters in North America and in Asia Pacific as well. So there's lots of opportunities to get involved globally. And we're always on the lookout for speakers, sponsors, and hosts as well. So if you're ever interested, please scan the QR code. It links you to my LinkedIn. There's also a form that you can fill out as well, but always happy to have a chat. We've got programs around kind of creating and supporting new speakers, as well as giving experienced speakers opportunities as well. And with hosting, we're always on the lookout, particularly in London as well. So we've got two amazing speakers this evening. And first up is Mahmoud. So Mahmoud, over to yourself.
Ethan, thank you very much. It's a pleasure to be here today. So I think that we spent around maybe 4 to 6 months going through as a journey, lessons learned, tough things we had to do and tough decisions. So I hope it's interesting and of benefit to everyone. So I'm Mahmoud. I'm a CTO at Bexprt. Bexprt is an advanced AWS partner, and we're quite specialized. So we do mainly AI and specifically Gen AI projects. We still have something we're very proud of, which is our resilience part of the business, where we go with customers throughout the journey. So we start first by getting customers to the cloud, whether it's a DR discussion or migration, and then we start landing into the innovation discussion around data and AI. We do absolutely do projects in UK and Europe, but we also have extended our work to other areas, specifically Riyadh or Saudi Arabia. So we have an office there. And we also do have a few projects across US as well, including the one we're going to be seeing today. Okay, so what I want to share today is mainly related to a solution we have, or a set of solutions under a specific suite we have, which is called Bexgen. We're going to focus on a specific part of that today, which is related to IDPs, Intelligent Document Processing. It's something that we have started with maybe 2 to 3 years back in terms of getting the best OCR technologies. Gen AI was still not mainstream as we see it today. So we had many services at the time helping us to read forms, to get the right data out of there. But as Gen AI came more center stage, as we started building more POCs, more agents with customers, we started founding this kind of framework around industries. So it's a framework where we have a specific set of core technologies we go to every customer with. It's all around even the enterprise features everybody is looking for, like single sign-on, a friendly user interface, being able to call the right agents and the right AI APIs, which is something that over time we were able to mature very well. But we have a story to share mainly around this intelligent document processing and how it was put along with agents to get through quite a tricky use case that we had with one of our customers. But on the way, we kind of learned a lot about LLMs, about agents specifically, and we want to share a lot about these today. So these are mainly lessons learned from the team. It's not my experience. All of it wasn't firsthand, but it's something that I was very close to and something I'm really proud that as a team we were able to achieve this. Okay, so it's a Fortune 500 enterprise. It's telco industry, and we had a very interesting use case coming through AWS. So as an AWS partners, we get always a chance to get into very exciting opportunities. In some cases, even co-delivered with professional services teams. So in this case, it was a customer that really had a lot of business critical documents, and these would not have a specific set of templates. You can group them into maybe 40, 50 document types, but even within each category, you wouldn't find a document close to another. So that's a big challenge. And that puts a lot of effort on the team that before the project were doing things manually. They have to read these documents coming through mail or sometimes email. They have to understand the landlord, the council, who's sending those documents around lease management. They have to classify them. They have to get the right info out of it and go to a database to match it. And based on that matching, they understand which team should handle this and put it into the right team. Being an automated workflow, they also need to do something more than that, or we need to do something extra, which is we need to score the confidence of being able to understand the information, get the right data, and score the matching itself with a huge database. So we have to put the right scoring that says how confident we are in terms of matching this with the right record, or in some cases, some suggested records if we have some matches that maybe we feel are very close in that case. It seemed a very interesting story, and it is actually an interesting story to tell, and we were very excited to start the project. We knew from the beginning it's quite a regulated environment. It's not an easy one to easily start putting AI within, lots of restrictions. Everything is easily putting off alarms when you put something that is not putting the right tag, the right configuration, and so on. And we wanted to ensure also that there's no unnecessary access, whether it's internet access or any public endpoint even, that we would not need. So we started this project with the goal of putting this in 3 months. We felt very lucky that we already, as an organization, we have a lot of written code. It's put as templates. It's tried already with other customers. So we were very confident about the plan that we can put it in the right time. So we have document ingestion code, we have CloudFormation and Terraform to help us in the right format. We have code to do for us extraction of data, or OCR, optical character recognition, classification, indexing. But what we really needed to write in this case, and we needed to get help from the customer as well to write very well, is an agent that would allow us to put all the right information in out of the extraction, indexing, and it would do some kind of reasoning, and that reasoning would call the right APIs, the right tools, as we call them, to be able to do the right action. So an agent, you can just think of it as a piece of software in this case that is meant to reason, to call the right APIs, and to be accessing the LLM, the large language model that we would put in this case. And I'm going to share a bit about that. So as with every project we do, let's start with a customer demo. Let's put a proof of concept for that. Let's get some sample documents and try to do like an MVP path for this. All good. And we were very happy with the results, customer happy. Let's start putting this to scale. This is where it becomes more interesting. So we want to build at scale. We're talking about thousands of documents. So the architecture itself is being revisited to ensure that everything is happening at scale. And although it wasn't the first encounter of doing projects where you have this LLM access, but usually, especially in the case of RAG and in the case of optimization, usually they have the chance to start maybe testing quality, fixing, and you're not very concerned about this scale. But when you start having automated flows and you have documents and you have lots of parallelism happening, this is where you start finding very small problems being really amplified. So in this case, we had like an average of 5 to 15%, depending on the models we were trying with, of hallucinations. The problem with these is that you have a specific workflow that has a specific output, and this output, which is scoring and routing, would really affect other systems downstream. So it's really, really important to do the things the right way. And one of the things even we started seeing when we selected an Amazon set of models called the Nova models, they have different levels like Light, Pro, and Premier. So when we started using those models, we were very happy that part of the security is already done for us. They are called content filters. If you have PII, which we already tried to filter out at the beginning, but if there's any PII, if there's any data that should not be passing through, if there's even any problems in the output coming back, the model itself, not the service, not Bedrock service, which AWS has a feature of guardrails, the model itself would filter this content and would tell us based on an error code that there has been filtration happening for a specific reason. So all these kinds of problems, including internal server errors that ideally happen when you are using very high scale or very high throughput actually access to LLMs, you start getting these problems. And this is where we started facing the first reality check. We have to see what we're going to do with this. We have a very short time frame. We really need to address those the right way. And we need to understand what we're going to do with each type of failure. So, okay, we have hallucination, that's fine. We cannot put it to zero, it's a fact. But what we can do is maybe let's try to detect first. Let's see if parts of the workflow, and that's why we started putting things as if we have checkpoints. We have very small tasks and actions when we go to LLMs, such that when we have a specific part of work where we have wrong output, where we have hallucination, we detect it and we do a retry. A simple retry works. So in some cases, when you do a retry, whether it's an internal server error, whether it's some kind of even unexpected filtration. So this is not PII, this is not, for example, content that should be filtered. A retry can help in this case. So that's something we would have in our code, in our loop. We have a workflow for each document, and the workflow has some areas for detection and retrial. But even more interesting, and that's something we realized maybe towards the end of the project, is that the kind of acceptance that there will always be those kind of errors, and even retries can sometimes not help, has pushed us into very helpful scenario, which is let's try to handle those. Let's try to go to a specific dead letter queue. So messages are not being processed once and twice, and even on the third time, they're still not going. No more retries. We're gonna, for example, handle this by showing the customer there has been specific error and gracefully returning what we already have in terms of the content extracted, and putting this in a very, very helpful way to anyone doing human in the loop or doing manual processing to be able to handle that. So that was really an important part of understanding what can you do if you cannot fix things. And to our surprise, the customer was happy with that. No problem. If you're already handling, for example, 95% of my use case, and there are cases where some minor number of documents is going to face this. We're fine with it. Customer is happy with that as long as we are putting this in the right path. We're not losing any document processing. We're not losing any kind of processing in this case. Last but not least, in terms of handling these kind of problems is validation. You need to have some deterministic code. I'm not talking here about another LLM, because there are cases where you can put another large language model, another, for example, judge that would try to validate information, try to see what went wrong and so on, and even correct the data. We favored, as we're going to see in the next slide, what we call deterministic fixing for that. So if you can write code, if you can write scripts, this is the best way for us to be very confident that if anything goes wrong, we have already things in place that will help us to validate the data we have. Most workflows, if not all of them, would always have some part which is non-deterministic, like understanding a specific paragraph or so. But there will always be checks, whether numeric, whether they are based on specific formulas, where you really have a way to check if you're getting the right data, if you have a regex that would check the specific value of a specific key in the output and so on. So this is where we really started putting the right checks in place, and I'm going to say more about these in the next 2 slides. Okay, so that was the first reality check. We were handling whatever we can in terms of the workflow to gain more confidence. But this is where we start hitting another reality, which is for the same document, run it 2 times, run it 3, 4 times. There's no guarantee that the output will be the same. The output in this case should be some extraction of fields, should be some kind of scoring according to a formula. So it should be the same. You're putting the same input, you're expecting the same output, but this is not what you expect with LLMs. Things very strange would happen over the way. In some cases, it could happen on the level of even very trivial thing, like that you have some text and all you're expecting from is just a summarization. A 0 can turn into an O. Some missing character for no reason would be removed out of a literal. You can name it. There's a lot of things that could happen on that. And this is where we go to the point I was just mentioning about trying to really find the portion of processing of our workflow where we can use LLMs, which we named as non-deterministic, to create for us the right code, the right scripts that can really help us in making a bigger part of the workflow to be that deterministic. We can even let the LLM put for us all the checks that we need to get the right logic. But what we really favor to do manually or do ourselves, even if it's not manual, but through other scripts, is to verify whatever was put to us as deterministic code. So we're going to have a function, we're going to have some script to do some checks for us. We prefer to inspect it. It's generated by an LLM, but we inspect it and we accept it as part of our security and CI/CD checks before we put into the LLM to be using in this case. In our case, it was a set of Lambda functions doing some code checks and so on. So again, what we really had in this case is we want to let the LLM do the non-deterministic task, which pretty much doing in a very good way, summarizing content, understanding intentions. All this was pretty much done very well. But whenever you want some parts to be really done in a deterministic way, it's math or it's a set of logic checks like scoring that you need to do in a specific way. We started using the brilliance of LLMs in chain of thought, in putting some terms of even use case validations or some edge case validation. We started putting this more into code. This code could be generated for us by LLMs. That was the second check. We have 2 more to go actually on this before I show you the architecture that we had just on a high level and how we had this solution architected. The attack vectors that we face once we get into a highly regulated environment, we have to pass by some gates, we have to have some even discussions with the right teams around security. and you find them really asking about very specific parts around prompt injections, around how you deal with the output, how you ensure there's no data leakage, and so on. We even, before all this, we had a very highly regulated environment to the extent that most of the services were blocked by SCP. So SCP is a service control policy. It's a very high level switch that AWS would put on a service called organizations, where you can just block the access of a service. So we had to wait maybe days, if not weeks, until we find the right team and unblock this, although we have the access to the service, but it's already blocked by an SCP. So you can just imagine how complicated this environment would be. We need to really, in a very short time frame, to go through all these checks. So some things really helped us, and I think they would apply to any project where you have Gen AI and I want to ensure there's a lot of guarantees in place if things can go wrong, specifically on the security side. So one of the things that we really found as a very good balance is that you don't have to go for the smartest model. When we talk about LLMs, we're always putting the capabilities and the least amount of hallucinations as the first metric, which is something understood and really acceptable. But in some cases, we found models, which is in this case a set of Amazon Nova models, that they would put acceptable performance. And when I say acceptable, it means that the majority of the time they are doing really well. Maybe they're not scoring as high as another model that would maybe score like 5% better in terms of accuracy, in terms of less hallucination, but at the same time, they would require a lot of extra work in terms of cleaning the data, in terms of stopping any wrong output, or even stopping anything that could go wrong. And we're dealing here with lots of documents, sensitive documents, many things can go wrong. So we decided to go for the Amazon Nova models. It was a very good choice. We didn't have a problem in the wrong filtration. In some cases, it wasn't much, but we had it in some cases because we have, as we spoke before, the set of retries, the set of graceful handling of errors. All this was really done in a smooth way once we have those functions and those validators in place. But another very important concept we had there is we really want to ensure that we have the right guardrails. And when I say guardrails here, it's not just about a set of switches where you want some language or some maybe terms to be blocked or unblocked. No, it's really more than that. I'm stealing actually this word soft and hard from one of the reInvent sessions of this year, which is the concept of having some guardrails that could maybe in some case spark some kind of correction, or let's say in this case it's gonna remove something and put another value instead of it, or mask something. All this is what we call soft guardrail. We're still doing the processing and we still have some guardrails in place, but we're not aborting this kind of workflow. But there are guardrails which we would call in this case hard guardrails that would stop the processing. There might be an attack happening. There is a smell of some SQL injection happening in this place. So this is a kind of guardrail where you're going to stop this document processing. This is flagged or marked as something that needs to stop immediately. And that's something that we've kind of learned the hard way, learned how we do it. And we saw some framing of this from other customers who have been doing similar projects, that you really have to invest a lot in those guardrails. In addition, for sure, that AWS has a set of guardrails that you can just switch on and off, but I would always say you need levels of those. It's always a layer of security checks that you need, so you can depend on some model or bedrock related ones, and you can have your own application specific set of guardrails. The last point we have here, which was really, really helpful for us in terms of the discussions we have with the security teams and passing the checks, is do we really need any internet access? Even if it's access through a NAT gateway, like just outbound, do we really need it or not? In most of the cases, where we found is that the customer already has the right landing zone, has the right infrastructure. We can go to the endpoints we need for the services. to do any kind of maintenance or any management or control plane layer access. It's always there through VPC endpoints. Even the load balancer, where the customer is going to access the application or the front end, no problem. It's already connected through a transit gateway from on-prem, so it's all private. So with this notion of zero internet access, we were always confident that most of the discussions would be released or relaxed a bit in terms of the attack vector and the discussion itself in terms of the checks needed for us for each and every entry point has really been lowered in terms of the barrier. So I think that's one of the things that I would recommend in any project to really check, which is, do you really need any kind of public access or public IPs or not? In our case, although we had lots of traffic back and forth between on-prem and AWS, there was really no need for that. Okay, so that's mainly it in terms of the things that we met on the way. I'm really happy to elaborate on those if we get a chance, maybe for questions after that or offline. But what I really want to end the discussion with here is just a quick run of the architecture. I'm not going to go through all the services, but I just want to highlight the impact that you would have if you had the heavy lifting done for you using serverless options. If that's an option you can do, you can see here API Gateway, S3, SQS, Lambda, all these are services that are running on a serverless fashion. AWS is doing the heavy lifting of managing the service. The scale itself and the security, a lot of this has already been offloaded to AWS and the expertise they have. We mentioned also VPC endpoints. They are pretty much everywhere where you access a database, where you access OpenSearch, which is for indexing the documents, where you start having metadata and access data. All this is happening on a serverless fashion. And maybe the last point to highlight here is that there's always access happening between the data center and between the AWS environment. So we were really thankful to the fact that we have the right networking in place, have a transit gateway, and even more than that, we have the option of being able to go over that with the right DNS. So the DNS resolvers running on AWS and also on-prem are able to translate very well the DNS that we have on both places. Sometimes we want to call an on-prem environment to pull data. Sometimes we want to push it to the cloud. So in both cases, we needed to have this kind of architecture. That's mainly it from my side. Thank you very much for listening in, and Ethan, back to you.
Perfect. Thank you very much. That was a great session. Before we move on to our second speaker of the evening, we'll just give it a minute or two for questions. I'll just see if anybody's got anything. But one question from me: what's been your experience trying to kind of bridge the gap between serverless and Gen AI? I think obviously serverless has been really popular over the past kind of few years, and a lot of major enterprise customers, including the likes of BBC, etc., use serverless quite well. How have you kind of found the bridging gap between serverless and Gen AI?
For us, it wasn't really bad in terms of being able to marry things together once it comes to finding the right APIs, finding the right way to retry and do the scale. But one thing maybe I really need to highlight here, because I've been bitten by a few times, which is once you have a scaling environment in terms of serverless resources, you start finding the IAM permissions, the checks that you have to do for each and every document to have the least set of permissions is not an easy job. So if we would say, for example, this is a set of functions that we would have put in an EKS cluster or a Kubernetes cluster, I think we would have reduced a lot of effort when it comes to IAM permissions, which is still something we have to do anyhow. But with serverless, you're really dealing with lots of moving parts, and each of them has to have its least privileged permissions. But overall, I think it worked very well having this kind of serverless resources, accessing what I would see even serverless LLMs, because with Bedrock, we don't have to manage, we don't have to host any of the LLMs. In our case, it was purely the vanilla models, no fine tuning, nothing needed. And I think the performance was really well as well on those serverless offerings.
Nice. Interesting. Yeah, I've heard a lot of good things around Bedrock. I've not had the pleasure of trying it out myself just yet, but yeah, I've heard a lot of people rave about it. It seems quite cool. But I'm afraid we don't have any more questions, but please feel free to reach out offline and have a chat there. But thank you very much for speaking this evening. And we will switch over now to our second speaker, Matheus. Cool. Welcome to the show. You're on mute, I'm afraid.
There you go. There's always one, right, that doesn't unmute. Hello, everyone. I just posted it on the chat as well, so you can find me on YouTube, also on LinkedIn and everything else. So I'm happy to always answer questions later, or if Mahmoud wants to come later as well and have a chat. I loved everything that Mahmoud just presented. I actually had lots of questions, and I was like, oh my God, this is gonna turn to a panel if you let me ask questions. But it's always awesome to see real solutions like that. But yes, how are you, Ethan?
Good, thank you. Not too bad. Slightly jet lagged, but getting there.
Oh yeah, you came from Canada?
Yes, yeah, just came back last night. So yes. Cool.
Let me start presenting my screen. Make sure that I've picked the right screen to begin with. Oh my God, this is always where things can go wrong. In the meantime, like I said, I am Matheus Guimaraes. I am a senior developer advocate for AWS, and I'm going to be talking about agents today. But most of all, how we transition from this old school world into this new world of agents. I am available on all platforms, so feel free to DM me later on if you want to ask questions or anything else. That's my LinkedIn right there on the screen. So feel free to scan that if you're watching this now, or if you're watching it later on demand. Then and I'm always happy to answer any questions. Now I want to start though by asking you, and you can all just answer mentally. If you're not answering in the chat, that's fine. When was the very first PC introduced? Does anybody know? Well, it was 1981, and that was the IBM PC. That thing right there, which for new generations look like something alien. So that was the first time the computers actually made itself into the mainstream. Of course, computers have been evolving for a very long time, but it was the first time that it actually went into our homes and our offices, and really started changing everyone's lives, everyone's jobs. Everything started getting certainly automated to whatever capacity it could at the time. And everybody started rethinking the world we live in. Of course, that kept on going. So the next big thing that happens is the internet. So do you know when the internet has its official birthday? Because there is one. So the official birthday of the internet is January 1st, 1983. Yeah, crazy. So, oh, somebody just said my first computer. You just showed your age if you said my first computer. Yes, it wasn't my first computer. My first computer was a 486DX, which had a button that you pressed on and it went turbo, and it went from 33 megahertz to 66 megahertz. But my mom had the IBM PC, and I remember playing Frogger, I think, on her computer. So I did play with it a little bit. Well, then came Netscape Navigator. I don't know if you remember that. Whoever said the IBM PC was the first computer, that means you were certainly alive for Netscape. That was one of the web browsers leading the whole internet coming to the mainstream alongside Internet Explorer. And it really, also responsible for a few crappy things like JavaScript. I'm going to get hate on the internet for saying this. But look, JavaScript was not meant to be a language. That's something that Netscape created just to have something like a cool thing on its browser, right? So you could kind of do some little UI stuff. It wasn't meant to take off the way you did. And then, of course, now all those problems are solved with standardization, so it's all good. But anyway, Netscape really charged that front to bring the internet to the mainstream. Unfortunately, it's not around anymore, but it definitely is something that most people remember. And when the internet came about, it was, again, world-changing, life-changing. Oh, yes, Mosaic. I knew somebody would call me out on that. Yes, I'm kind of discarding the text-based web browsers. This is a pain I don't want to remember. But the internet started changing again the world and the way we behave in society. Online retail, everybody thought, no way, nobody's ever going to shop online, bank online, as if. And look where we are now, right? So once again, technology just kept evolving and changed the way that we deal with the world around us. Okay, something a little bit more modern. The cloud. Who invented the cloud? AWS. That's right. All the way back in 2006, officially. A little bit before that, when we released SQS in beta and all that. But officially 2006, AWS came out. And then just once again, changed a lot of the paradigms of software development and how we think about software. It came at a time where computers had taken off, internet had taken off. Now what happens? We need to scale. We need to really take this to the next level. So the cloud enabled you now to have your websites or whatever scale to thousands of users across the globe at any point. And that kind of flexibility, again, changed the way we develop software and made distributed architecture easier. So microservices then come out and start, again, challenging the ways that we used to do things. OS2, gorgeous. Oh, well, there is some art in that. I will agree with you. But and nostalgia, of course. But the new generation will look at OS2 and go, what? But anyway, microservices then made distributed architecture a bit more accessible, although introduced complexity. But it was yet another layer of abstraction that now was made available and mainstream because of the evolution before it. Because the cloud now made it easier for us to implement these things and apply infrastructure at scale in much simpler ways. And then with microservices, of course, came a flood of data, because now we have all these distributed systems all accumulating data in their own silos. If you're doing database per service pattern and all that, that means that now we have big data. And big data then led us to something that it's a little bit more niche. I don't know if you would have heard of it, but in case you haven't, it's something called AI. So we had to figure out what to do with all this data. And eventually, even though machine learning and AI has been going on for the longest time, thanks to our tech god, Alan Turing, and others, McCarthy, then we really just started taking off with some events that happened, 2017, transform architecture and all that, and then transform into something that we can really take to the next level and once again transform society and the world as we know it. So our homes start changing, our software started changing, our jobs start changing. And yeah, see, I'm not being repetitive just because I'm old and confused. It's because that is the pattern. Yes, AI is hugely transformative technology, but we've been here before. Software developers have been dealing with this challenge to the status quo forever, ever since the beginnings of time, right? That is what technology does and how it works. So at first, these huge changes seem very revolutionary, but if you stop to think, they're not a revolution, it's an evolution, because everything that we do today, including AI, is based on everything that we've been doing before. And the puzzles may be different, but the patterns are the same. And for any old timers like me, and maybe like you, LinkedIn user, who has been around and had the IBM PC and all that, you can tell that there is a lot of similar patterns to everything that we do. And once you understand that, then you can really start delivering the potential of this new technology and taking as a thought leader into new realms and new areas that we never thought was possible. And that's because digital transformation is a continuum, right? It's not a reset button. So every transformation builds up on the next, and then continues on until we learn new patterns, new abstraction layers, and then new scale, new requirements. But of course, we know it's not that simple either, because every digital transformation is formed by loads of other technologies that we've already been doing that come before it and continue to evolve alongside these new things, right? So whether it's cloud, microservices, or agents, we all still need to know, where do you store your data? How do you encrypt your data? How do you keep it secure? How are you going to move it around? How are you going to expose it to users? Website, mobile apps, whatever else comes next, VR. How do you actually make sure that everything's compliant and you're observing things to make sure that nothing's failing in production, or to proactively make sure things don't fail? None of this goes away. All of that just evolves, and then you just have to kind of rethink, relearn, and reapply. And that's what humans do best, because after all, birds were given the power to fly, dogs are given the power to sniff and hear. We are given the power of technology. This is what we do. This is a natural power. So you just gotta learn, embrace, and apply. And everything else comes with it. Nothing is ever reset or lost. It just evolves. So to make my point, let's compare, for example, microservices with agents, right? So starting with microservices, they are loosely coupled, right? So that means that microservices are independent units of deployment, which also should be independently maintained and released and all that stuff. And agents is no different. We want our agents to be independent, right? They live in their own island, and then the applications or anything else, all the other clients, connect to the agent for that state machine finite operation that the agent will decide what to do and return the output to your client or whatever may be calling it, right? So loosely coupled is something that still continues to repeat itself. How about composability? So microservices are meant to be composable, meaning you can mix and match them and create even new functionality without having to code again, if you're a good architect. You can even discover new features that you didn't think you could do simply by composing them in different ways. Agents are the same thing. So you can have agents talking to agents and now starting to unlock really clever stuff that you didn't even have to code yourself. They're interoperable, both of them. Microservices can have their independent technology stack. You can have one in .NET, another one in Node.js, another one in Python, and they can all still communicate through standardized communication protocols and patterns. Same thing with agents. We have reached an age now where agents can talk to each other. You can use Strands Agents SDK to create one agent. You can use LangGraph for another. You can use Crew AI for another. It doesn't matter. They can still all function on the right abstraction layer where we all need them to talk to do something useful and bring business value. And finally, specialized. So microservices are very much about single responsibility pattern, the bounded context. What is it that microservice does and does it well? And that is the one thing you should do. For example, crude example, but a customer's microservice, a product microservice, a purchase microservice, whatever. And agents is very similar. So now you're going to have an agent that, for example, is specialized in booking flights. The other one specializing in making recommendations, looking up flights based on requirements from the customer. The other one specializing in hotels, so on and so forth. And together they can create a travel agent system, all by themselves with their specialization by being composed together. So again, the patterns are the same. If you take it to the architectural level, you start recognizing a lot of what we've seen before, only that you got to learn the implementation detail and boom, off you go. So if you are an architect that goes deep into that kind of stuff, you are well set up for success to deal with AI, much like you've been dealing with everything else before. So it's something that you definitely should embrace, because AI and agentic AI has been on a curve, but it has been a really, really fast journey, because we are in what I kind of call version 3.0 personally of agentic AI, of generative AI in general, actually. For me, version 1.0 was back then in 2022 when ChatGPT decided to release their products to the world and capture the public imagination. Now, generative AI and AI has been going on for a very long time before that, right? In AWS, we always said also our AI services, Transcribe, Poly, and so many other ones. But what happened in 2022 is that technology, the generative AI technology, captured the public's imagination. That is huge for technology when that happens, right? Because now everybody's thinking about that, not just us, the technical people. But version 1.0 was very much the world getting used to the idea of request response. We ask something to the model, and then it comes back with an answer. And that was already, wow, right? Really cool, tap into this big brain. But that's just synchronous request response. Cool. Then we moved to version 2.0, where agents came into the picture. And with agents, the main difference is that they can make decisions, autonomous decisions. So instead of you actually guiding through code, if this, then that, and then you make a request to the LLM, then the agent can go, actually, I think the best way of doing this is this way and that way. And I'm going to call this or that. It's not going to ask you. It's going to do those things. And that is surely the main difference with agents. It is the fact that they can take action, not just interpret something and return the result of that interpretation, right? And then we fast forward now to version 3.0, what I call 3.0, which is the full agentic AI systems, where it's not just one agent, it's multiple agents. Again, do you see a pattern? When we went from monoliths to distributed architecture and all that, very similar. So for me, before the 2.0 was almost like monolithic. We had an agent and we loved that idea. So we hooked the agent up with loads of stuff and ask whatever I want to ask, and it would do loads of stuff. Now the pattern is more get a specialized agent, like I mentioned, the flight booking one, and then connect them, and then they can all start talking to each other in standardized ways as well. So this is where we are at now. And you may be thinking, wow, this moves fast. Yes, but it's moving fast in a logical progression. And there are many mature tools already because of the speed that you can use to cover all these facets. So let me tell you really quickly, if you are coming to AWS, how we can help you in all of these little phases that you have to go through to get to a production AI system. Starting with development. So the developer tool that I recommend that you should really try today is Kiro. So this is something that we released. It's out there. It's open. You can download today and start using it. And we pioneered something called spec-driven development, right? So all this means is that Kiro goes through phases. Instead of just jumping into coding, it will act like a real agile team, like the humans that you interact with at work. And you gather everybody for a requirements gathering meeting. Then you're going to kick off your scrums. Hopefully you got a scrum master that done all the process for you. You're going to have your stand-ups, your sprints, all that. And Kira kind of simulates that kickoff process by getting as much context as you as possible about what you want to do, but then presenting a design, presenting an implementation plan, and then starting coding. And as you guys know, with AI, it's all about the context, right? The more context, the better. The richer the information, the better the results. That's exactly what happens with Kiro. That's why the results with Kiro are far superior to other things that were coming on before, because it's structured that way. It's structured to have as much information as possible. Highly, highly recommend. This is like, it's not just because I work for AWS, it's highly transformative, like for your developer workflow. So I really recommend you give it a go. Then you're going to need to actually start working on a backend at some point. What are you going to use to call foundation models? This is where Bedrock comes in. So Bedrock started as a serverless portal to quite a few already foundation models back then when we launched, but it has evolved rapidly and now gives you access to hundreds of models, even through the Amazon Bedrock marketplace, where you can even have Hugging Face models directly deployed through the Bedrock framework, which means you can access those models through the Bedrock API. Bedrock has a very cool differential, which is the Bedrock Converse API that I love. And the reason why I love it is because you have all these foundation models, but you can have the same block of code, just one block of code, and literally just change the model ID, and boom, you're now connecting to a different model. Any of those there out of the box. You just need to find the model ID and change it. That makes the code repeatable, testable, and really easy to experiment with to see different results. And you don't have to redeploy. You want to change your model at runtime in production for some reason, whatever reason you may have, no problem. Just stick that on an environment variable and then change that variable, and then the Bedrock will be calling that model instead. So, it's really flexible. And another thing, a lot of people, think like, ooh, AWS, don't say ChatGPT, don't say OpenAI. Well, guess what? You may know by now, AWS and OpenAI are deep into a really cool partnership, a multi-year partnership. And now not only we have OpenAI models, the open weight models available through Bedrock, but as you may know now, ChatGPT is also running on AWS for scale. So you got all your options here from multiple partners, Meta, OpenAI, and many other ones, as well as the Amazon models, Amazon Nova, for you to choose from, all through Bedrock. Okay, then how do you actually build the agent? So you can talk to foundation models now using Bedrock. How do you build the agents? You have many frameworks, but we released something about July last year called Strengths Agents SDK. It's open source, and so you're free to go on GitHub and browse it and use it. And it's so easy. It's agnostic as well, by the way. It's not tied to AWS. It makes AWS easier. So if you're working with Bedrock and all that kind of stuff, of course, we can make that easier for you. So that's built into it. But you can work with anything, really, and compose these things together to create your agents. And this may look like a lot, like there on the screenshot, until you actually start reading it and realize that that's all English. That's just the prompt. That is the code that you use to create the agent. It's simple, it's quick. So again, really easy for you to experiment with, or just to put a POC together. But the good side of it, the good thing about it, is that you can use this for POC, but it's also production grade. So you can take the same thing to production and you'll be good. It's not just something to create agents quickly. It's something that you can use long-term together with Bedrock, together with Kiro. Okay, but then that takes us to production. We're ready to put this in production. How do you do this? We realized there was a gap in 2025. A lot of our customers wanted to put their AI workloads into production, but then they started hitting these things, these challenges that they hadn't thought about until they went to production with it. Things like integration, things like security, and a lot of other stuff. So we wanted to make life easier for everyone to kind of plug the gap and have an end-to-end solution of services for you to choose from. And that's when we released Bedrock Agent Core. So Amazon Bedrock Agent Core is all about having your this specialized runtime where you can run your agents, and it knows about these specific agent concerns to run agents in production. So abstracting a lot of the concerns while giving all the power of configuring things and taking control over the things that you want to implement or not. Now, Agent Core is not just one thing. It's multiple things, right? Multiple services that you can opt in and out of choosing what you want to use or not. The first one, the obvious one, is the hosting. So Agent Core Runtime is what you're going to use to actually host your agents in production. And it does many wonderful things for you. For example, it isolates sessions. So every time you talk to an agent, you're starting a session as a user, right? So I ask something, my sister asks something. Now, we have to make sure those conversations don't bleed into each other, especially if the context is going to mess up the responses and create even more degrees of predictability, let alone data privacy concerns and all that. So what Agent Core Runtime does, it creates a micro VM every time a session starts. So it splits it into a new micro VM dedicated to the session, to me, to my conversation. And then once that session is over, it obliterates it. Boom. Those resources are reclaimed and that session is gone. So there is full isolation between sessions, conversations, and then they also go once they're done, which means enterprise grade stuff right there out of the box for you, among other things as well. Now, another thing that Agent Core has is Agent Core Gateway. And for the architects out there, you probably will appreciate the good architecture thought put into this. Why? Because Gateway is a way for you to connect your Agent Core agents into their tools, right? So you can group all your tools behind this gateway, and then your client only needs to talk to this gateway to access all the tools, instead of, as opposed to you having to hard code the access and everything else to these tools in your agent code. So much more maintainable. It's almost like inversion of container and dependency injection, because you're putting everything behind the gateway. You can at any point go to tool 1 or tool 4 and update it, take it down, replace it, remove it, without having to redeploy or affect your code, right? So really cool stuff there. These endpoints could be either OpenAI 3.0 specification RESTful APIs, or they could be AWS Lambdas as well. Put everything behind the gateway, then you only have the one endpoint to worry about from the agent. Much like an API gateway pattern, but made for the 21st century agentic AI era. The other thing that Agent Core has is identity. So this is for security. When you connect your agent to all these tools, and by the way, if you're not familiar with the terminology of tools, tools just means anything that you integrate with, right? Could be APIs, could be databases, could be internal systems, could be SaaS software, could be anything. So tools is just technology, things, systems, data that the agent can connect with. And when you connect to those things, they're all very different, right? So if I want to connect my agent to Gmail, and then I want to connect my agent to Outlook, they're both email systems, but they're very different. So they can have different libraries and protocols and security and things, right? Like AWS stuff, SIG v4, all that. So what identity does is centralize that, again, into a gateway pattern. There you go, went back into a gateway pattern where you have the outbound auth endpoint, and then your client will only connect to that endpoint, and then behind that you configure all your credentials. Also comes with pre-built stuff. So for the popular stuff that you connect with, like for example Google stuff and all that. So it's got like a pre-defined credentials thing that you can just also have out of the box, or you can also deploy your own. Agent Core Runtime, by the way, has both identity and gateway built into it, but you can actually use them separately if you only want to use identity for your agents, if you're building with something else or hosting somewhere else as well. Then finally, we got Agent Core Observability. So there are specific concerns with agents when they go to production that you want to watch out for. So are the responses being unpredictable? Are we leaking important data into the prompt? So the responses as well. Is the agent connecting successfully to all these tools? Are there any bottlenecks? Are there any prompt injection concerns? All that. So the Agent Core Observability will keep track of your agent conversations and turns and all that kind of stuff, and allow you to visualize it. And the cool thing is that it has integration with OTel already, so OpenTelemetry. It will ship out those OpenTelemetry logs for you to directly integrate with anything that you may already have. Like, if you got your Grafanas and your stuff, you can just integrate with it. Or if you use CloudWatch, so this is the Amazon CloudWatch, this is the AWS service, then you can also use with CloudWatch out of the box, and then you just have all your nice observability metrics right there for you to continually monitor, but also get alerts on. So the AWS stack, AI stack, has a lot of stuff, as you can see. We really have something that covers every single part of it. Whether you are on the applications level, where you want the highest level of abstraction because you're focused on business productivity for your teams, or whether you are on the development level, so now you're dealing with Bedrock, you're dealing with foundation models and code and all that, or whether you are maybe an AI business or something, and then you need to actually train models and go that deep down, then yes, we got things for that. We got SageMaker, we got Trainium, we got lots of infrastructure as well for you to do your thing from the ground up. So it's a lot of choices. My recommendation is, I always find it's easier to be prescriptive. Stick to, if you're starting with AWS and AI and want to start exploring and learning, start with Kiro plus Bedrock plus Trends plus Agent Core. Those four will cover the whole spectrum of your AI development and enable you to take it from literally your POC, from the very bare bones, to all the way to production. And by the way, I I usually say these days that the chatbot is the new hello world. So if you're really getting started, my recommendation is build a chatbot, literally a simple chatbot using these tools, using this stack. And that will really get you familiar with all aspects of it. And like I said, for me, truly, that is the new hello world. You can't go wrong with that. The last thing that I want to leave you with is also, although while this is all very amazing, not everything needs to be an agent, right? So you don't need to start jumping into a digital transformation to agents and nullifying everything that you've done before, right? That's not how things work. So to take back to what I said in the beginning, digital transformations are not necessarily reset buttons. You can and you should adopt agents slowly, kind of like with the microservices, strangler fake pattern, right? You can slowly find that use case and then apply it. So for example, when would you use an agent? You use when you need decision-making, when you need a multiple step workflow, so multiple things that you connect to that agent, and then it can decide, oh, I'm gonna use this API, I'm gonna use this database by itself. You also use an agent when you need that context awareness. So you're not constantly going back to the database and say, give me 10 rows of this, 20 rows of that, 30 rows of that. Now I know what I want. No, the agent can think in context and already derive the decisions and actions from the context that it keeps. And most of all, also, when you really need something intelligent, right? We are moving to a world where we are going from just worrying about compute to having to deal with intelligence. And that is what's new. So if you take, for example, an app like Expense Tracker, and you need to upload receipt images, you need to store and retrieve expenses, and you need to generate some reports. Is that an app or is that an agent? Anyone? So that is an app. If you thought an app, then you're right. Why? Because these are very deterministic actions, right? There's no thinking involved here. Upload receipt images, it's a finite operations. Give me some storage, give me an endpoint, I'll put my receipt images there. Store and retrieve expenses, well, that's a get and a post, right? And generate summary reports, that is an operation that is deterministic. So this may be a nightly build job, or some daemon process or some batch process, I don't know. But either way, this is a very deterministic operation. There's no intelligence involved. So how about customer ticket classifier? Classifier, that sounds a little bit machine learning-ish. Let's see, classify ticket text into categories using a foundation model. Store and retrieve tickets from database. Route to the right support queue. Now, you could argue that maybe this is an agent, but it doesn't have to be. By default, this is an app. Why? Because you can still use generative AI as part of a normal application flow. It doesn't transform it into an agent necessarily. So classifying ticket text into categories using foundation model, yes, that's generative AI, but that's just intelligence behind an API. So you can use Bedrock and all that, put it on an API, and then you are using generative AI, you are tapping into that intelligent brain of the foundation model, but all you got is a much smarter API, which you absolutely should have. But you don't need the full-on agent, which will introduce patterns that you're gonna have to think about. And they are over-engineered for what this problem requires. Store and retrieve tickets from database, again, get post, route to the right support queue. This is where you may argue, but couldn't this be a little bit intelligent? Well, yes, but it depends on the threshold, right? Requirements, business value. So if I only have 2 support queues, yeah, that could be easy. If it's anything technical, go to support. If it's anything customer complaints or anything, go to this other queue. Done, right? That doesn't take much. But let's say we actually change that more into deciding whether to automate, escalate, or create a GitHub issue. Ooh, that's complex. And now we're actually taking action as well, a dynamic set of actions. So, agent, use context from past tickets to resolve faster. Agent, determine knowledge source dynamically. Agent. And this is where the multiple support queues could come into place, right? If you got really a lot of decisions to be made, a lot of different support queues, a lot of nuances, then definitely we want that intelligence in. So agent. Now, if you do just an app, you would end up with this, right? If it's bug then go here. If it's this, go that. Else, if else, if else, if else. That's what I'm going to have a massive switch statement. And you can still have your microservices, your independence, all the good stuff that we know about distributed systems, but it's coming down to having to control those things in the code. Whereas with an agent, this is what happens. Everything becomes much more simpler. You have the agent, and then all those if and else's become SCP. So you have a standardized protocol. You just connect every single microservice or systems or SaaS software, whatever you have, to the agent and let it get on with it. And in case you're not familiar, MCP and A2A are the two standardized protocols, which is crazy to think they are the mainstream standard, but they are. Even though MCP just was released, like December 2024, November or something like this, and A2A May 2025, and they are both now mainstream. And all it is, the difference is that with MCP is when you have your agent and you're going to connect to these tools, remember, APIs, SaaS software, database, whatever. So this is the protocol that they all talk, kind of like HTTP for the web, but this is for AI. And then you just hook up the agent with these MCP tools, and they all understand each other without you having to do much, really, to be honest. That A2A, the clue's in the name, agent to agent, is when you want this agent to talk to this agent. So agent, tools, MCP, agent, another agent, A2A, and then this agent, MCP again to its tools. That's the difference, right? So agents are super, super, super powerful things, but not everything needs an agent. So remember, all these technologies that underpin this technology, much like any other digital transformation, you still have to worry about data stores and containers and SaaS and API, serverless or not serverless, storage. All those concerns are valid with agents and without agents. They are just new considerations and new patterns to apply. But remember, puzzles may be different, patterns are the same. One recommendation I'll leave you with is to go to AWS Builder Center, especially if you're starting with AWS, because we have a lot of centralized learning resources here in Builder Center. We also have a wish list feature where you can directly tell us, AWS, what kind of features you want or things that you would like to improve. You just put it on the wish list. And there is builder spaces where you can connect with communities, much like this one. This one should have a builder space on Builder Center so that you guys can go and share stuff. And there's much more coming. So please make sure to sign up for it. You just need a builder ID, which is free. Just do like your email confirmation, done. And that is your identity with AWS. And there's a lot of really nice prizes coming in 2026 for this. So please make sure to check it out. Thank you very, very much for your attention. I'm more than happy to answer any questions either here or on socials, DM, or out there in the circuits. I'm always out there speaking at events as well. And make sure to check out my channels, Coding Matheus everywhere, every platform. I do a lot of educational videos. So yeah, it would be awesome if you check them out.
Perfect. Thank you very much for that. That was an exceptional talk. I think even slightly better than when you did in London. So yeah, that's great. Perfect.
Also refreshed.
Yeah. And please make sure to follow Matheus on LinkedIn and YouTube, etc. He does some absolute amazing content. So yeah, and funnily enough, you have an amazing specialism within .NET as well. So I'm hoping to see a lot more content within that area as well. So,
yeah, .NET microservices is like my jam, and AWS, of course, like the perfect tri-marriage for me.
Definitely. Cool. We'll give it 1 minute to see if we've got any questions. But before we do, I've got a question myself. What's been your best use case of agentic AI that you've kind of seen?
To be honest, I literally just hosted a hackathon last week. And it was massive. It was an AWS hackathon called Breaking Barriers Challenge 2026. It was a whole week thing. It was like a 3-day thing. And it was a lot of charities that came together and proposed some problems that they have, like real world problems that they want to solve for their for the real business and workloads. And a lot of people came together for the hackathon to bring solutions for that using agentic AI. I cannot even tell you, like, some of stuff was even hard to kind of stay composed and smile on stage because there was some really moving stuff. But for example, One of them was a virtual therapist to help people direct themselves to care who don't have enough time to wait before they get to care. So it's like a pre-care thing with human in the loop and all that kind of stuff. So it was pretty cool. There was more practical ones, like there was a charity that needed support with reporting and making that report more real time and directed to the right humans to act quickly to support people and help people and make decisions. So the agents were pretty much contextualized with all these data that the charity has, from assessments and evaluations and professionals and all that, to help them with the volume, because their teams need to cope with scale to help as many people as possible. I mean, there's so many, honestly, I don't even know. It was fantastic. So people are really taking even the simple chatbot to new heights, to really help people and help the world. And I love seeing that.
Yeah, definitely. There's some fantastic use cases, as you mentioned. Yeah, that's brilliant. Cool. Well, I'm afraid we don't have any more questions, but please feel free to reach out to Matheus offline, and hopefully, we can go from there. But I want to say thank you very much to everybody who attended this evening. I hope you have a lovely rest of your week. And please feel free to follow us on Meetup. We've got some amazing other events planned later this year. So yeah, have a great evening, and we will speak to you all soon. Perfect.
Thank you very much. Thanks, Ethan, and thank you, everyone. See you around.